All right, in this podcast, we're going to talk about things called the pKa and the pKb values for acids and bases. All right, so the relationship between Ka and Kb and pKa and pKb is it's basically just the negative log base 10 of the Ka or the Kb will give you the pKa or the pKb. Everything is still on a base 10 logarithmic scale, just like pH. But here, you're just negative logging the Ka value to put the Ka value on a logarithmic scale, which we'll call pKa. All right, so here's a little example. So if the pKa for HCN is 9.31 at 25 degrees Celsius, what's the Ka? Okay, so we know that, pKa is equal to the negative log of the Ka. And we know that to solve for Ka, because that's what our problem's asking us to do, we need to do 10 to the negative pKa. So 10 to the negative 9.3, and that's going to give us our Ka value, and it ends up being 5 times 10 to the negative 10th. All right, so let's just talk about some general trends for pKa. So here you see that we have acids. If you look at their Ka values, you see they're listed from the very strongest up here to the very weakest down here. Now, if you'll notice, the Kas get larger as the acid gets weaker. And then the smaller, even into the negative region, the pKa is, the stronger the acid. All right, PKBs. So again, it's all about looking at our KBs. So here, this one, very large number, don't even give us a value. And then you see that the numbers get smaller and smaller. So that means they're getting weaker and weaker as we're going down. And then you see that the PKBs, they're kind of doing the opposite. So as the KBs are getting smaller, the PKB is getting larger. And then the bigger ones, the very strong ones, have the smallest or often negative pKb. There's a relationship between pKa and pKb, and it's pKa plus pKb equals 14, just like pH plus pOH equals 14. So if you know one, you can find the other through this little formula. All right, so this last little example kind of wants us to bring it all together. So the first thing it asks for is the pKa value for the acid. You see that we were given the pKb value right here. Okay, so we know that pKa plus pKb is equal to 14. So we plug in our pKb right here and solve for pKa, and we get a pKa value of negative 1.5. So hopefully that tells you immediately this is a very strong acid here. It's definitely an acid because it has a small pKa value. It's even in the negative region. So this is definitely an acid. And it also says that it wants to know if the conjugate base, which was what we were given the pKb for up here, if it is a stronger or a weaker base than water. Okay, so the pKb value was 15.5. So I kind of think of this in terms of my Kb value. So my Kb value is going to be 10 to the negative 15.5. That'll give me my Kb. And so my Kb ends up being 3.16 times 10 to the negative 16th. Okay, now I also know that Ka times Kb equals Kw. So for water, the Ka and the Kb are supposed to be 1 times 10 to the negative 7th for both of those values. And that is definitely bigger than this, which means that water is the stronger conjugate base. So this particular conjugate base I have is definitely weaker than water.